Okay, we're now on to worksheet number 4, vector addition by components. Looking at the first problem, it's talking about vector addition using the Pythagorean theorem. Remember that the Pythagorean theorem is the square of the hypotenuse equals the sum of the square of the two sides. So in this case, we'll call them A and B equals C. So our first triangle says that it is 4 meters to the north and 3 meters to the east. So our resultant vector, remember, goes from the tail of one to the head of another, and this would be our side C. So using our Pythagorean theorem, we can say that the square of side C is going to be equal to 3 meters squared. Remember to put it in your parentheses so that you're squaring the number and not just the unit, plus the sum of 4 meters squared. So that would equal 9 meters squared plus 16 meters squared, which would equal 25 meters squared. And then we take the square root of that, and so we know we take the square root of both sides. We know that C is equal to 5 meters. On the top of this problem, it says PSAYW, which means please show all your work. If we flip over to problem number 2, which is going to be similar, problem number 4, which will be similar to problem number 2, we can see that we have a little bit more of a complicated problem here. We have someone, say, hiking through the woods, and they make several different turns. So we'll send Jordy out to the woods again. He goes 5 meters to the east, and then he goes at an angle, 12 meters, and then he walks east again for 4 meters. So in this case, it's a little more complicated to determine the resultant displacement. But again, we remember that we go from the beginning of our walk, or the tail of the first vector, to the head of the last vector. This will get our resultant vector. Well, this doesn't look like a right triangle to me, so how do we work from there? Fortunately, we were given a few more pieces of information in our problem. We were also given that this angle, which we can call theta, this angle is given as 30 degrees. So, having that information, we can now determine the two sides of our right triangle, because we know that the hypotenuse is 12 meters, and we have the angle. So we can use our sine, remember our mnemonic, SOHCAHTOA. So we have the hypotenuse, so we're either going to use sine or cosine, and we have the angle. So we can first find the opposite side. We have our angle, we have the opposite and the hypotenuse. So in our calculator, we put the sine of 30 degrees times our hypotenuse. So we remember that sine equals opposite over hypotenuse. Since we have our hypotenuse, we can say that the sine of that times the hypotenuse will equal the opposite side, just rearranging our equation algebraically. So when we put that in our calculator, we find out that the sine of 30 is 0.5, and 0.5 times 12 is going to give us 6 meters is our opposite side. So we can fill that in here. To get the magnitude of the adjacent side, we're going to use our cosine function. So in the same way, cosine is equal to adjacent over hypotenuse. Again, we had our hypotenuse, so the cosine of 30-degree angle times our hypotenuse of 12 meters will give us the adjacent side. And so when we plug that all into our computer, we determine that our adjacent side is 10.4 meters. So how does that help us get our whole resultant triangle? Well, we can now take the information that we have and draw a whole new right triangle. And I don't know if that got lost on the board or not, so I'll put that there. Sorry. Okay, so if we draw a whole new right triangle, again with our resultant vector being the hypotenuse, and then we can add in here. So how do we determine these sides? Well, we know that the bottom side is 5 meters plus our 10.4 meters that we just determined is the side of this right triangle, plus the 4 meters at the top, so that we know that the base of this triangle now is 19.4 meters. We know that this was 12 meters because that was a given, and we can determine that the height of the triangle is still 6 meters, the same as the height of this triangle that we determined over there. So we can fill that in, and then we can use our Pythagorean theorem to find we could use a Pythagorean theorem if we knew these two to find that, but we can also add those together. And so then if we want to figure out the angle of that, we can go with any of the sides that we have and determine the overall angle of theta. So we haven't used our tangent function yet, so let's use our tangent. So the tangent of angle theta is going to be equal to the opposite over the adjacent. And so our opposite is 6 meters, our adjacent is 19.4 meters, and so that is going to equal 20 point. It's going to. Oh, and then we do the tangent. So we can say tangent to the -1 because we have to undo this to get our actual angle. So tangent to the -1 times the opposite over the adjacent will give us 17.2 degrees as the angle of theta. So hopefully you can apply all this to the problems on worksheet number 4 and conquer it.